Hello guys, and welcome in our new tutorial. I found this part and we are going to program this today using Multiaxis toolpaths. So first we are going to select the machine. I'm going to select lace and one of our Integrex machines. And now we are going to assign a stock. Before that, I'm going to select the plane and I'm going to move the plane to that will do. F9 to select our axis. Okay, that's okay. I'm going to use this plane plus D plus Z. And let's go to toolpaths manager, and in a stock setup we are going to hold this material in the left spindle. We are going to use 68, that would be okay, 250, and we'll select jaws, not defined, so we're going to define it, and that'll be fine. Let's select the grip and let's grip it 60 mil inside the jaws. Nice. Okay, I'm going to save a quick mark. Before I start doing anything else, I'm going to switch off material rendering so you can for you guys, so you can see things more easily. And this is the part that we are going to cut. It has some divider plus a pocket. We are going to use few multi-axis toolpaths, and we will start with along the curve. We will use two variants to cut the parts across and along, so you see the difference. Okay, so let's start with our programming. To keep things organized, I'm going to create additional geometry level, and everything that I'm going to create I'm going to put on this one. I mean, like additional geometry that I'm going to create. So let's go to surfaces, and you can find program fill holes. Click on it and then click on the surface where you have your hole, drag the cursor next to the hole, and Mastercam will create a surface filling the hole. Okay, so now we can select our first toolpath. So as a first toolpath, we're going to select along curve, and we're going to finish this floor here. So go to milling toolpaths, and in multi-axis in the pattern you have along curve. In the tooling page we're going to select our tool, and let's use 10 mil ball nose, should be enough for roughing. Set your speeds and feeds. And as a tool holder, we're going to select HSK, and this one will be fine. Our tool projection, which is stick out length from the holder, going to set 120. As a cut pattern, we're going to select our lead, and we're going to select this radius. I want to show you what it does to the toolpath. So notice that our toolpath, our start of the chain is here on the top, and you see how it does affect our toolpath. And of course our drive surfaces, so what we want to cut are these two. Hit OK, and let's just leave it as it is at the moment, and let's see the toolpath. So our lead started from here, and you see the toolpath starts here as well. So it goes first here and then finish this side. Okay, so now let's adjust it. I don't want to start in the middle, do half and then go back and start again. I just want to do from one end to the other side in one go. So we will move now. We are going to move now the lead. Start somewhere here, and let's see how it affects our toolpath. So let's go and edit it. Dynamic, start end, and let's move it somewhere here. Oh, one moment. Let's move it here. Let me go in this way. Okay. Let's see the effect. And as you see, we have one entry and one exit on the other side, and our arrow was pointing this direction. So the start is here, go around and exit. Nice. Okay. To finish the walls around this floor we just finished, we are going to use a new toolpath that Mastercam 2021 added to their list. It is in application section, and we're going to use pocketing. Okay, select pocketing. For this one I'm going to use something smaller. Maybe let's use bullnose, maybe 6 mil. Okay, flute length 40, shoulder length 60, overall length 125. Okay. We can set our speeds and feeds here. So feed rate 1.5, plunge rate 1.5, 12,000 spindle, and retract. Now let's leave it like that. Our tool holder, we are going to use this tool library, and I'm going to use 16, and I'm going to hold the tool 100mm stick out length, tool projection. Okay. In the cut parameters, we are going to, in the pattern, we are going to select what we want to do. We can rough the pocket, we can floor finish or wall finish. So I'm going to finish walls, and I'm going to morph contour from the top edge to the bottom edge of the wall. The part surface is basically everything, so let's select the part. The floor surface is that what we just machined, so this is our floor of this pocket. And the wall surfaces, so we want to machine those around. Okay, and let's have a look. Let's leave it as it is at the moment, and we will do fine-tuning later on. Let's see if it generates what we need. Okay. It actually looks okay. So these are our two operations. I'm going to run quick simulation. I'm going to check quickly if there are any plunges or... Okay, so we have everything finished except the bottom here. Okay. Now, as we have our pocket finished, we can go back to our settings, do a little bit of tweaking to get better finish. So let's go back to our along the curve, and we are going to change the step over and cut tolerance in order to get better finish. The step over I'm going to change to 0.1mm and the cut tolerance at 0.05. Basically, the tighter it is, the better finish you get. Also, I'm going to take extend trim as I want to shorten the toolpath a little bit to avoid hitting the walls. And I'm going to use value of 0.03mm in both start and finish. And of course, positive value extends the toolpath, negative value shorten the toolpath. So don't forget to put the minus in both of them. Next setting page we are going to adjust is collision control, and we are going to add a second level of the collision control, and we are going to select our check surfaces, and action of the tool is to tilt the tool automatically when it hits one of those surfaces, check surfaces, so our avoidance geometry, and select the walls around the pocket. Let's double check few things. Advanced option for surface quality, okay, and cut parameters is all okay. Maybe on the tool axis control, let's change maximum angle step to 1 degree and hit the OK button. Regen our dirty operation, and let's wait for our toolpath. At first sight it looks okay, but to be sure, let's verify the operation and we'll see if our collision control works okay. quickly go through it. Okay, it still looks good, but let's have a look and compare it to the 3D model. Well, as you see, our tool still hits the side walls. So let's go back to our toolpath and I'll show you how to fix it. Go to parameters along the curve toolpath, and in our tool axis control, as a tilt angle, we're going to use -5, so it will keep the tool 5 degrees away from the wall. And on the subpage, advanced options for tilting, we're going to gradually change this tilt to opposite side, so it will keep our tool side away from the walls on the opposite side of the floor. Let's quickly run the verify and compare option to see if it's okay against the model. So what we did is, in here, this -5, we start here and the tool is tilting -5, and then when it goes to the other side along the toolpath, it's gradually changing the tilt to 10 degrees. Okay, so again we got the lead and we moved the start to here, and when the lead start is here, it will start doing the passes from the same point. And our drive surfaces, we selected these two. Tool axis control is 5 axes, and these are all standard settings, but we set our start cutting -5 and gradually side tilt angle change 10 degrees. As our next toolpath, we are going to use along curve again. It's in slightly different way. So inside this pocket, our toolpath produces the cuts along the part. In along curve toolpath, they are always 90 degrees to the lead. So if lead is that way, cuts will be along. If the lead is along, the cuts will be across. So now we're gonna select a line that's gonna be along the part, and it will force Mastercam to generate the toolpath across our drive surfaces. Before selecting our next operation, we have to create lead, and we'll do it by using line endpoints from wireframe tab. Okay, so I want my line to start at the center of this diameter. Select the edge of this diameter, and it would go through the part up to this diameter here, to the center of this diameter. And to make it easier for us to see, I'll make it a little bit thicker. So this line we will use as a lead for our next operation. So now let's select our multi-axis operation, and we select along the curve again. Going to use a 6mm and ball nose end mill. Type your feeds and speeds. In the holder page, we don't need to select any holder, as we used the tool in one of the previous operations. On the next setting page, cut pattern, we start from selecting our lead. Press add button and select the line we just created. The line that's going through the center of the part, and click OK. Now select your drive surfaces. So this is the surface that you want to cut. In our case, we're going to select the floor around the pocket we already finished, the remaining floor. Okay, press end selection. I'm going to change maximum step over to 1, even 3 mil. It should speed up the generation of the toolpath, and I don't want to extend or trim the toolpath, so I'm going to switch that off, and I'm going to leave everything as it is just to see the toolpath. Okay, because it remembers the settings from first along the curve operation, I need to switch off the collision control for now and press OK. Okay, our toolpath looks okay. The path is the direction I wanted. And because our lead is, let's say, along the part, our passes are across, because the toolpath is generated 90 degrees to the lead you selected. So now let's select our check surfaces. So as a first thing in the collision control page, I'm going to activate level 2, and I want to tilt the tool, the strategy, and for this example I'm going to switch off level 1, and I'm going to add those drive surfaces to the tilt strategy. Click the selection button, and let's select all the walls around that floor, around that drive surface we selected, as we don't want to hit them. To our check surfaces, add also the fillets between the floor and each wall. Okay, last few faces around our floor, and we will do some additional settings to our tilting strategy later on. Let's first have a look how the toolpath looks like, and if we get what we want, select OK, regen, dirty operation. Okay, let's see our toolpath. Right, so we see now quite a lot of retractions, and for example, this is caused by the settings that we're going to change now. In the cut pattern page, we have a sorting option to machine by. At the moment, our sorting strategy is set to machine by lanes. It basically wants to finish one full pass before it moves to another one. Let's change this to regions, and it will tell Mastercam to finish each section before moving to next section. You can see it on example here. So this option will let us to minimize the retractions. Let's see if we will get still those retractions above this blade here. Okay, this is the toolpath. It looks better. We don't have jumping the tool above this blade here. There's still some motion that I don't like here, but let's do some additional settings. Go to parameters, and in the cut pattern page I'm going to change my step over to 0.3. If you want a low bear finish, you can change it to 0.1. I'm going to leave it as a 0.3, and I'm going to leave settings on this page as they are. All looks good. Let's have a look to our tool axis control. I'm going to change the tilt angle to 0. Mastercam remembered the value from the first toolpath, and also this one needs to be changed to 0. Now let's move to Lincoln setting page, and we change the small gaps to 10 millimeters as value, and we want small gaps to follow the surface, and if the gap is greater than 10 millimeters, we want to retract it to rapid. Click OK, regender to operation, and let's see the result. Okay, that looks good. I see a problem here. So as I said, we machine by region, so I went first, finish one side, and then move to finish this side on the other end. I'll show you a small trick. See, based on your lead, Mastercam divided droid surfaces in region as you see now. Sometimes a Swarf, for example, moving, you see the lead, just move it up or down or left or right, in our case maybe left or right. Let me guys demonstrate that to you. So let's move the line using dynamic transform. Let's move it just 1 millimeter. In the result we should get slightly different toolpath. If not, we'll move it again. It works quite well if you have a droid surface with multiple regions and you have multiple sections that you machine. Let's see what result we can get in our case. If not, we will move the lead slightly again. Oh, look at that. That's different. And actually, you don't have this big move behind the part. So let's have a look how this is getting done now. Let's go in the same side. Okay, it stops here and finishes it on the other side. Okay, that would do. Okay, well, let's go back to parameters of our toolpath. Let's do some additional settings to our tilting strategy in the collision control. Select the gauge checkup parameters for tilting. So these are settings for collision control tilt tool strategy. And direction, we're going to leave relative to rotary axis as it is, and rotary axis we have to change it to X because our part lies in the X axis. And below you can select the tilt angle and your preference. You have equal tilting, rotary tilt or a tilt. We go by the tilt. Let's regen our toolpath again. Okay, that looks a lot better. Okay, I can live with this. Now we have our floor finish. Let's take care of finishing the walls around this pocket, around this floor we just finished. And to do that, we're going to use pocketing operation, the new pocketing operation, and I'll show you how to control the tool tilt in this new toolpath. Okay, so let's finish those walls around the floor. Let's copy and paste the pocketing cycle we already have. And in the parameters, we're going to cut pattern settings. And let's remove everything and select part surfaces as to our whole part. Okay, and the floor surface is just this floor we finished. It is the surface, the face we just finished in previous operation. And the wall surfaces are the surface that we want to cut. Select the wall around the pocket. We're going to leave everything as it is and see our toolpath. Okay, Regender to up, and this is our toolpath. The toolpath actually looks okay. The only thing I can see is the tilt of the tool. If I hold the part in the left spindle of my multitasking machine, the tool might hit the left side of the wall of the machine, as the tilt, as you see, is quite big. So let's have a look what we can do, and I'll go with you through the settings. Let's go to parameters and in the tool axis control, and our tilt is based on the contact point, and 3 top positions we use to control our tilt: preferred contact point, minimum contact point, and maximum contact point. So let's set our minimum contact point to 50%. So I don't want to go anywhere below 50% of my cutting length, and my maximum I'm going to set to 85%. I don't want to go above. I don't want my tool to wrap the side of the pocket, so I'm going to leave it as 85. And the preferred contact point is what you want Mastercam to achieve if it's possible. So we are using the ball nose, and 50% is roughly about 45% of the tilt. If you go by 0%, your tool will be normal to surface. So, and if you set it to 100%, it would generate the tool path with the tool cutting using the side of the tool. And also on this page you can set your lead angle. So you select your preferred lead angle and then set your minimum and maximum lead angle you want Mastercam to use. Okay, let's regender to operation and see the result now. Okay, we can see straight away that the tilt is not as big as it was before our change. So this is the easy way to control your tilt of the tool. I'm happy with the result. Let's have a look quickly how it looks in Verify. Okay, I can see that we achieved what we planned, what we wanted. The tool tilt is very small and it runs almost vertically, so that's good. In the next step, I'm going to show you how easy it is to cut the fillet with the tool using Morph toolpath. Okay, come over to Mill and Tap again, and we select our next operation. So select the Morph toolpath in Multiaxis. Going to use 6 mil, and because we selected the tool with the radius the same size as our fillet, we're going to cut it in one pass, and we will set it up later on in cut pattern page. So this is my speeds and feeds. My tool is going to be 6 mil. I don't need to select the holder because we already selected that on the previous operation. In the cut pattern, we're going to select our cutting parameters, and we start with selecting our curves for our pattern from. Switch to the solid mode selection, and as our pattern from, select the top edge of the fillet you want to cut. No. Going this way, that way, around, and here. Okay, so this is pattern from. I selected the top edge of the fillet. Okay, so this selection is ready. Click OK button, and select bottom edge for our pattern 2. Remember to start roughly in the same position and go to the same direction. Okay, and select bottom edge of the same fillet that you want to cut. Okay, so going around here, there. Okay, and here, finish. So it goes here on the bottom edge of the fillet around. Okay, in the area section of this page, if you select your type as full avoid cuts at exact edges, you can set your maximum step over in this box here, all the scallop height in the box below, in millimeters everything, because we are using the metric settings, as you can see here. This toolpath is explained more in details in our impeller tutorial, so don't forget to check it out. But in our case we are going to use this option and select number of cuts as 1. Let's go and select our drive surfaces. So we are going to cut the fillet around, so select the whole fillet between the floor and the walls. Nice. And selection. And let's have a look at our toolpath. So our pattern from is the top edge, and we use curves, and the pattern 2 we are using the bottom edge, and as our drive we select the surface between the two patterns. Okay, I see a problem here. Okay, see this line that indicates our tilt is quite big. Oh, yes, it actually doesn't touch the faces on that wall, but look at the angle, plus the holder, plus my spindle column, and it may hit the chuck because my chuck is quite big. So let's going to modify a little bit our tool axis control. Let's switch it from 5 axis to 4 axis, and let's have a look what happened. We have all these straight walls, that's what these are, but those are vertical. So let's have a look. I think it should be okay. Look at that. My tool is now nice vertical position. I don't care about the tilt this way. I just don't want tilt to the side, to the chuck side. Okay. The only one thing left is to finish this guy here, and that's the last toolpath in our today's tutorial. The last toolpath that we are going to use today is going to be swarf milling. Let's use the swarf from the pattern, swarf milling, not from application. Okay. And again, let's use one of the tools that we already have. I think the radius and the bottom is 5 mil, yes. Yes, 5 mil. So let's select this tool. Holder, we've got pre-selected as we are using this tool before in other operation. Cut parameters. So in this page we are we have to select the geometry that we are going to machine and to control our toolpath. So in the Swarf surfaces, that is a must that you need to select, that you have to select. So let's select those surfaces around. And floor surface, we have a floor, so we can select the floor. Let's use this. Okay, so the rule is you have to select the Swarf and one of these three. You can use Swarf surfaces and tilt lines, or Swarf surfaces and guide curves, upper rail and bottom rail. Then you select the top edge and the bottom edge of your dry surface, and let's leave everything as it is. You can select your side, you can select direction of the cut. I'm going to go climb. You can guide your tool at the lower curve or at upper curve, and start point, you can select your start point. Then you select a line or two points where you want to start your toolpath. Let's leave everything here as it is. The output, I want 5 axes, and gouge check. Let's do Swarf surfaces and the gauge. Let's have a look at the toolpath. And this is what we have. Okay, all looks fine. So this is all we need. Let's save it. Okay, let's run this job in Machine Simulator, and thank you all for watching the tutorial. Don't forget to download your 3D model from the link in the description. Also, you can find the Mastercam Home Learning Edition link in the description. And if you like the video, hit the like button and subscribe for future videos. Take care, guys.